Hi guys, I've got a question here which I'm going to use as an example of how to use differentiation in an exam. What we've been given is we've been given a question which asks, find the equation of the tangent to this function, this cubic function, at the point 2, -1. Now, a tangent line to a function is a linear slope which shares the same gradient as the function at a particular point. So the equation of the tangent line, because it's linear, is going to take the form mx plus c, with m being the gradient of the linear function and c being its y-intercept. Now what we're going to do is to find the gradient. We're going to differentiate this cubic function, and then we're going to substitute in the point in question, i.e. x equals 2, and that will give us what the gradient is at x equals 2. So let's go ahead and do that. What we need to start with is we're going to differentiate this. So dy dx is going to be equal to 3 times 2x minus 5 all squared, and then we times by the derivative of the inside function. Okay, now we're going to just clean this up a bit. That's maybe just because of personal preference. You can leave it like that if you feel like it. Doesn't really matter. 2 times 3 is 6. 2x minus 5 all squared. So that's our derivative. Now what we have to do is we have to evaluate this derivative at x equals 2. So I'll just get a different color, make it a little bit easier to see. So we have dy dx evaluated at x equals 2. That's going to be equal to 6 times 2x, which is 2, minus 5, all squared. So 2 times 2 is 4, minus 5 is -1, squared is +1, times 6 is just 6. So what we get from that is that m is equal to 6. So then what we do is we plug this newfound value into our linear function that's asking us to find. So we're going to have y equals, instead of m, we're going to put 6x plus c. And then what we're going to do is to solve for c, or find its y-intercept. We substitute in the points from the original that they give us, 2, -1, and then we'll be able to solve for c. So because that green's not very easy to see, I'll change to black. So y is equal to -1. So 6 times 2 plus c. So we can say -1 equals 12 plus c. Then we can just go up to here and go take the 12 over the other side and go c is equal to -13. So once we've got those two values, we just have to write the equation of the tangent line down. So we can just, and a statement if you feel like it, so you can write, therefore the equation of the tangent line is y equals 6x minus 13. And there's your answer. So basically what we've done is we've used differentiation to find the gradient of our linear tangent function, And then what we've done is we've substituted in the values that they give us at the point to solve for c. Now, if we're ever asked to find a tangent line to any type of function, whether it be cubic, whether it be quadratic, whether it be trigonometric, whether it be exponential, it always follows this rule. Always follows these steps, sorry. You find the gradient, you substitute in the points and solve for your y-intercept. So I hope this video helped you understand that process, and I'll probably catch you next time. Thanks.